Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal and this is a lecture on time and work. In this lecture, we are going to solve 18 practice questions on time and work. So let us start with the very first question. If P men working P hours per day for P days produce P units of work, then the units of work produced by n men working n hours a day for n days. So the relation between all the variables are m1 d1 into h1 e1 upon w1 equal to m2 d2 into h2 into e2 upon w2. So putting these values in the variables in the question, so m1 is given to be p, d1 is given to be p, h1 is given to be p, and w1 is given to be p. So m2 is given to be n, d2 is given to be n, h2 is given to be n, and w2 is unknown that we have to find out. So substitute the values in the formula, you will get p times of p upon p is equal to n times of n upon w2. So w2 is equal to n cube upon p square. So that is n cube upon p square days. So option correct here is option D. Question number 2. X number of men can finish a piece of work in 30 days. If there were 6 more men, the work could be finished in 10 days less. Find the original number of men. In this question, we have two variables, men and days. Hence, taking these two variables and draw the formula, we have m1 d1 equal to m2 d2. So m1 equal to x, d1 equal to 30, and m2 equal to x plus 6, d2 equal to 30 minus 10, that is 20. So we have all the values, and this we have to substitute in the original formula. So we will get 30x equal to 20 times of x plus 6, that is x equal to 12. Therefore, original number of men is equal to 12. So the option correct here is option C. Now, question number 3. Some persons can do a piece of work in 12 days. In how many days? 2 times the number of such person will do half of the work. So let the number of men be m who can do work in 12 days and unit of work be w. So using the formula m1 d1 upon w1 equal to m2 d2 upon w2. So we have m1 equal to m, d1 equal to 12 and w1 equal to w. So m2 will be twice of m because it says in the question. So we have twice the number of person we have earlier. D2 is unknown and W2 is half of the work, that is W by 2. Now substitute these values in the given formula. So we have m times of 12 upon W equal to 2m times of D2 upon W upon 2. So D2 will be m times of 12 upon 2 into m, that is 3. So the number of days that twice the number of person that earlier were doing the work will do half work in 3 days. So the option correct here is D. Question number 4. 12 monkeys can eat 12 bananas in 12 minutes. In how many minutes can 4 monkeys eat 4 bananas? So 12 monkeys can eat 12 bananas in 12 minutes. So this is given in the question. So the formula that we are going to use here is m1 t1 upon w1 equal to m2 t2 upon w2, where m1 and m2 are monkeys in two conditions and t1 t2 are time taken. So let the required time be t minutes. So according to the question, 12 into 12 upon 12, that is equal to 4t2 upon 4. Therefore, 4 monkeys eat 4 bananas in 12 minutes. So the option correct here is option C. Question number 5. One tap fill a Christine in 6 hours and another tap filled the Christine in 8 hours. How long will they take to fill the Christine if both taps are open? So time taken by X is 6, Y is 8, so the total capacity is 24. So now the 1 unit value will be 24 divided by 6, that is 4, 24 divided by 3, that is 24 divided by 8, that is 3. So the total X plus Y will be 7 unit of value, and the final answer will be given by the LCM, that is total capacity upon the total unit value, 1 unit value, the efficiency. So it will be 24 upon 7. The option correct here is option B. Now, question number 6. 3 pipes can fill a tank in 4 hours, 6 hours, and 8 hours respectively. How much time will they take when all 3 pipes are opened together? So we have A equal to 4 hours, B equal to 6 hours, and C equal to 8 hours. So when you take the LCM of these three, you will get the total capacity of the tank that we are trying to fill. So its capacity is 24 units. Okay. And now we have to see the efficiency of A, at how much time what is the efficiency at which A fills the water in the tank. So 24 divided by 4, that is 6. 24 divided by 6, that is 4. 24 divided by 8, that is 3. So when they have to work together, all of these three, A, B, C, so they together fill 13 units of water in a single day, single hour. So the total time taken by them will be 24, that is the work done, that total amount of work that has to be done, or that total capacity that has to be filled. And in 1 hour they do 13 units of work, so it will be 24 upon 13 hours. So the option correct here is option A. Now, question number 7. One tap can fill a tank in 2 hours and another can empty the tank in 3 hours. How long will it take it to fill the tank if both taps are opened? So, very interesting question. There is a tank in which there are 2 taps, one of which is used to fill the tank and another is that can empty the tank. So if I turn on both the taps, so from one end I'm trying to fill the water and from the other end I'm trying to take out the water. So definitely one tap fills the water in 2 hours and another empty the tank in 3 hours. That means there is faster rate of filling the tank is more. Tank get filled faster. So how much time will it take to get the tank filled completely? So X is equal to 2, that is fill, and Y equal to 3, that is empty. So the total capacity of the tank is LCM of 2 and 3, that is 6. So the unit value, 1 unit value is of X is 3 and Y is minus 2. Why we put minus here? Because here the water level is decreasing. Correct? Y is not increasing the water level. So it is decreasing it. So when they both work together, the amount of work that is done or the amount of water that is poured per unit time is only 1 unit of amount of water is filled per hour. So X plus Y, the total capacity is 6 and the total work is the efficiency is 1. So it will be 6 hours. So 6 hours will be required to fill the tank when from one end we are filling the water and from the another we are taking out the water. So the option correct here is C. Question 8. Two pipes A and B can fill a tank in 9 hours and 12 hours respectively, while a third pipe C can empty it in 6 hours. How long will it take to fill the tank if all the pipes are open together? So we have A equal to 9 hours, B equal to 12 hours, and C equal to 6 hours. So let us first try to find out the total capacity of the tank. So the total capacity of the tank is 36. Okay. And what is the efficiency of pipe A? It is 4. Efficiency of pipe B is 3. And if you see, C is trying to empty the tank. So again, we have to put a minus sign here, and its efficiency is -6. So the total efficiency, if all these three pipes work together, will be 4 plus 3 minus 6, that is equal to 1. So the total time taken when all three pipes work together is 36 hours to fill the tank to completely. So the option correct here is option D. Now, question number 9. Two taps can separately fill a tank in 10 minutes and 15 minutes respectively. And when the waste tap is opened, they can together fill it in 18 minutes. In what time the waste pipe can empty the full tank? So till now in the questions, we calculated how much time will it take to fill the tank completely when one of tap or pipe is trying to take the water out. But this time we have to find how much time will it take to empty the tank completely. So let us have a look over the solution. So A takes 10 minutes, B takes 15 minutes, and time taken by C to empty the tank is unknown. So now LCM, the total capacity. So is okay. Here we also one information is given. So when all of these three work together, it takes 18 minutes to fill the tank. Okay. And the LCM is 90, that is total capacity. So the efficiency of A is 9, efficiency of B is 6, and the combined efficiency is 5, 90 upon 18. So it will be 9 plus 6 plus some x minus x equal to 5. So that gives us, you have to simplify this. Okay. So it will give you 10. So the time taken by pipe to empty the water will be 90 upon 10, that is 9 minutes. Question number 10. 3/4 part of the tank is full of water. So when 30 liters of water is taken out, the tank becomes empty. Find the capacity of the tank. So in this question, if tank has 4x liters of total capacity and it holds 3x liters of water, and if 30 liters of water is taken out, then the tank becomes empty. That means they are trying to say that 3x amount of water is taken out of the tank. That means 3x is equal to 30 liters. That is given to us. So x will be 10 liters, correct? So the capacity, we assume capacity to be 4x liters. So just substitute the value of x to obtain the precise capacity of the tank. So the capacity of the tank is 4x is equal to 4 into 10, that is 40 liters. So the option correct here is option C. Question number 11. A pipe can fill a tank in X hours and another can empty it in Y hours. In how many hours can it together fill it if Y is greater than X? So let A takes X time and B takes Y time to empty the water, and A takes X to fill the water. So the LCM is going to be XY, that gives a total capacity of the tank. And efficiency of A is XY upon X, that is Y. And since B is trying to empty, we will again put a minus sign here. So the efficiency of B will be XY upon Y, that is minus X. So the combined efficiency of A and B is Y minus X. So A plus B will be XY upon Y minus X hours. So the option correct here is option D. Question number 12. 12 pumps working 6 hours a day can empty a completely filled tank in 15 days. How many such pumps working 9 hours a day will empty the same tank in 12 days? So here we are going to use the relation that says M1 D1 H1 E1 upon W1 equal to M2 D2 H2 E2 upon W2. In this question we have M1 equal to 12, D1 equal to 6, H1 equal to 15. Okay. Now M2 is unknown, D2 is 12 and H2 is 9. So putting these values in the formula, you will get 12 into 15 into 6 equal to M2 into 9, 12 into 9. So M2 will be 12 into 15 into 6 upon 12 into 9, that is 90 upon 9. So D2 is 10. So the option correct here is option C. Question number 13. A boy and a girl will fill a tank with water. The boy pours 4 liters of water in every 3 minutes and girl pours 3 liters of water in every 4 minutes. How much time will it take to fill 100 liters of water in the tank? So time taken by the boy to pour 4 liters of water in 3 minutes. Therefore, the quantity of water poured by boy in 1 minute is 4 by 3 liters. Correct? And the time taken by the girl to pour 3 liters of water is 4 minutes. That is given in the question. So the quantity of water poured by the girl in 1 minute will be 3 by 4 liters. So the total water that is poured in 1 minute by boy and a girl is 4 by 3 plus 3 by 4 liters. That means 25 by 12 liters. And since 25 by 12 liters water poured by a boy and a girl in 1 minute, then 100 liters of water poured by the boy and a girl will be 12 into 100 upon 25, that is 48 minutes. So the option correct here is option C. Question number 14. 3 pipes A, B and C can fill a tank in 6 hours. So after working together for 2 hours, C is closed and A and B fill it in 7 hours more. How much time taken by C alone to fill the tank? So part of the tank filled by 3 pipes is A plus B plus C in 1 hour, that is equal to 1 upon 6. Therefore, part filled by in 2 hours will be 2 upon 6, that is 1 upon 3. Therefore, the remaining part is equal to 1 minus 1 upon 3, that is 2 upon 3. So the part filled by A plus B in 7 hours is given by 2 upon 3. So therefore, A plus B's 1 hour work is 2 upon 21. Therefore, the part filled by C in 1 hour is equal to part filled by A plus B plus C in 1 hour minus the part filled by A plus B in 1 hour. So which is equal to 1 upon 6 minus 2 upon 21, that is equal to 3 upon 42, or we can say 1 upon 14. So C alone can fill the tank in 14 hours. So the option correct here is option A. Now, moving to question number 15. There are 2 pumps to fill a tank with water. First pump can fill the empty tank in 8 hours while the second in 10 hours. If both the pumps are opened at the same time and kept open for 4 hours, then which part of the tank that will be filled up? So it is given that x equal to 8 and y equal to 10. So this information is given to us in the question. So the total capacity is given by LCM of 8 and 10, that is 40. So one unit value, that is efficiency of x, is 5 and efficiency of y is 4. So total efficiency, or I should say combined efficiency of x and y is 9. That is 5 plus 4. So in 1 hour, 1 unit capacity of both the pipes is equal to 9 units. Therefore, in 4 hours, both the pipes fill is equal to 9 into 4, that is 36 units. The fraction of part filled is equal to 36 upon 40, that is 9 upon 10. So the option correct here is option A. Now, question number 16. 3 pipes A, B and C can fill a tank in 6 hours, 9 hours and 12 hours respectively. B and C are opened for half an hour, then A is also opened. What will the time taken by the 3 pipes together to fill the remaining part of the tank? So it is given that time taken by A is 6 hours, time taken by B is 9 hours, and the time taken by C is 12 hours. So the total capacity of the tank is 36 units, and efficiency of A is 36 by 6, that is 6, 36 by 9, that is 4, and 36 by 12, that is 3. So the combined efficiency of A, B, C is 6 plus 4 plus 3, that is equal to 13. So in 1 hour, B and C can fill a tank 7 units. Therefore, B and C can fill a tank in half hour, that is 7 upon 2 units. So in half hour, B and C together filled 7 upon 2 units of water in the tank. So remaining unit of the tank is 36 minus 7 upon 2, that is 65 upon 2. So time taken by all the pipes to fill the remaining part of the tank will be 65 upon 2 upon 13, that is equal to 5 upon 2. That is 2 of 1/2 hours. So the option correct here is option C. Question number 17. 2 pipes A and B can fill a tank in 36 minutes and 45 minutes respectively, while a third pipe C can empty the filled tank in 30 minutes. So the first 2 pipes are opened simultaneously, and after 7 minutes, pipe C is also opened. In what time the whole tank will be completed? So A is 36 minutes, B is 45 minutes, and C is 30 minutes. So the total capacity of the tank is 180. The efficiency of pipe A will be 180 upon 36, that is 5. Efficiency of B will be 180 upon 45, that is 4. And efficiency of C will be 180 upon 30, that is minus 6. Since C is trying to empty the tank, so we put a minus sign here. So the combined efficiency of A, B, C is 3 units. So for 7 minutes, the first 2 pipes A and B are open. So in 1 minute, pipe A and B can fill 9 units. Hence, in 7 minutes, pipe A and B can fill the tank. That is 9 into 7 equal to 63 units. The remaining part of the tank is equal to 180 minus 63, that is 117 units. Now all 3 pipes are open, that is the remaining 117 unit of tank is filled by all 3 pipes A, B and C. So the time taken to fill the remaining part will be 117 upon 3, that is 39 minutes. So the total time required to fill the tank is 7 minutes plus 39 minutes equal to 46 minutes. So the option correct here is option C. Question number 18. 2 pipes A and B can fill a tank in 4 minutes and 6 minutes respectively. If these pipes are turned on alternatively for 1 minute each, then how long will it take for the tank to fill? So here A is given to be 4 and B is given to be 6. So the LCM A and B is 24, that is the total capacity of the tank, and 24 divided by 4 gives the efficiency of A, and 24 divided by 6 gives 4, that is efficiency of B. So the total efficiency of A and B together is 10. So in the first minute, tank is filled by pipe A equal to 6 units, and in the second minute, tank filled by pipe B is 4 units. So therefore, in 2 minutes, tank is filled by A and B equal to 6 plus 4, that is 10 unit. Therefore, in 4 minutes, tank is filled by A and B equal to 2 into 10, 20 unit. And in the 5th minute, tank is filled by a pipe A, because in odd intervals of minute, pipe A occurs. So the remaining 4 unit is filled by pipe A. Since 6 unit is filled by pipe A, that is 1 minute, and 4 unit is filled by pipe A, so it will be 4 upon 6 minutes, that is 2 upon 3 minutes. Therefore, the total time taken will be equal to 4 minutes plus 2 upon 3 minutes, that is 4 minutes 40 seconds. So the option correct here is option A. So thank you very much. That would be all for this lecture, and I suggest you to try these questions by your own, and I'll see you in the next class with more questions on time and work.